Hello everyone, this is Dr. Zach, and today we are going to be working with Rolle's theorem and the mean value theorem in AP Calculus. For today's lesson preview, you are trying to draw a function that did not have a horizontal tangent line. And as you found, if your function was continuous and differentiable everywhere, then there was no way to draw this function if the 2 points had the same y value. And that leads us to Rolle's theorem. For Rolle's theorem, we have a couple of conditions that must be met. F of x must be continuous on AB. To be continuous, that means the limit as x approaches some value from the left of your function has to be equal to the limit as x approaches some value to the right of the function has to be equal to the value of the function at that point. Your function must also be differentiable. And in order for a function to be differentiable, remember it must be continuous and the limit as x approaches the value from the left of the derivative has to be equal to the limit as x approaches a value from the right of the derivative, and that also has to be equal to the derivative at that point. And the last condition is that f at a must be equal to f at b. Now, if all three of these conditions are met, there is at least one number c such that the derivative is equal to 0. So if f at a equals f at b and your function is continuous as well as differentiable, then you're guaranteed to have a horizontal tangent line somewhere along your curve. For our first problem, I did not write your domain. The domain that we will be thinking about is the x's are traveling from 0 to 1. All right, so the first condition, let's check to see if f of x is continuous. As you look at your function, you can see that the function is continuous from 0 to infinity. So f of x is continuous on 0 to infinity. Don't include that endpoint. Second part, we want to think about differentiability. F prime of x is equal to 1/2 minus 1/2 x to the negative 1/2. The endpoint, you can see, is 0, would not exist for this function, but that's quite fine because it is differentiable on 0 to infinity. So let's look at our third condition. F at 0 is equal to 0. F at 1 is equal to negative 1/2. Now, since f at 0 does not equal f at 1, Rolle's theorem fails. So our function might have a 0 as its tangent line for the slope of its tangent line, but we cannot determine this from Rolle's theorem. As we look at number 1, notice that we're going to find the two x-intercepts and show that f prime of x equals 0 at some point between these two intercepts. To define the x-intercept, we're going to factor, and from the factors, we know that the domain that we're interested in is going from -6 to 0. In order to verify Rolle's theorem, make certain that you talk about continuity, make statements about the continuity. You know that f of x is continuous on -6, 0. What else do we know? We know that we're going to talk about differentiability next. F prime of x is equal to 2x plus 6. So you'll make a statement, f of x is differentiable on your -6, 0. And lastly, you want to look at the third condition. Does f at -6 equal f at 0? And what you find out is that f of -6 there does equal f at 0 because they're both 0. And therefore, we know that Rolle's theorem use the words when you're using Rolle's theorem or even the mean value theorem next. Holds, and there is some point where f prime of x is equal to 0 on -6, 0. Next, you're going to try questions numbers 2 and 3. Make certain you make statements for all of the pieces that are expected in order to show that Rolle's theorem holds or Rolle's theorem fails. So Rolle's theorem is actually used to prove the mean value theorem. For the mean value theorem, if f is both continuous on your interval and differentiable on your interval, then there must be some number c on AB such that the derivative is equal to the average rate of change. So remember, please, the average rate of change is just another way to find the slope of a secant line. So what the mean value theorem is saying is that your slope of the tangent line must be equal to the slope of the secant line if your function is both continuous and differentiable. So we know from Rolle's theorem that if you have 2 points A and B that are equal, so here's A, here's B, and your function is both continuous and differentiable, then there exists a horizontal tangent line. Well, coming up with that, let's draw a secant line from A to B, and you will see that the slope of the secant line is 0. So the slope of the secant line is equal to the slope of the tangent line for Rolle's theorem. Now, if we tilt both the secant line and the tangent line, then it follows from Rolle's theorem that the slope of the secant line must be equal to the slope of the tangent line at some point between A and B. For our second example, we're going to determine if the mean value theorem applies to f of x on the interval 1, 4. And then once we determine whether or not it applies, we're going to figure out where the slope of the secant line is equal to the slope of the tangent line. So first, talk about continuity. F of x is definitely continuous on 1, 4. It is not continuous at 0, but that's okay because our function is only on 1, 4. Talk about differentiability. F prime of x is equal to 4 over x squared. So f of x is differentiable on our interval 1, 4. Once again, it's not differentiable at 0 because it has a vertical asymptote, but we're not interested at what happens at 0. Therefore, we know that the mean value theorem can be applied. Mean value theorem is MVT, can be applied. Specifically, we know that the slope is going to be equal to, the derivative is going to be equal to the slope of the secant line, which is your average rate of change. When you find f of 4 minus f of 1 over 4 minus 1, you're going to take 4 over x squared and set it equal to 1, which tells us that x is equal to plus or minus 2. Now, as you can see, x equals -2 is not on your domain, so we will exclude that as one of our solutions. So what we know is that f prime at 2 is going to be equal to 1, and this was guaranteed by the mean value theorem. So the mean value theorem can be applied. And f prime at 2 is equal to 1. Now, how this is used might be something similar to this following example. A car enters your turnpike at 9 a.m. and travels 260 miles and exited the turnpike at 12:30. Use the mean value theorem to prove that the driver should be charged and fined for excessive speeding during his trip. So let's talk about being continuous and differentiable. So traveling by car is definitely a continuous trip, and it should be a smooth trip, so it is also differentiable. Therefore, our mean value theorem can be applied. And what does that do for us? That tells us that the instantaneous rate of change, f prime at some value c, is going to be equal to the slope of the secant line at some point. Well, we don't have any points right now. So at time equals 0, you entered the turnpike. And at 12:30, you exited the turnpike. So that would have been 3.5 hours. You have traveled 260 miles. So we know that the slope of our secant line, which is your average rate of change, is 260 minus 0 over 3.5 minus 0, or on average 74.298 miles per hour. Go back to your mean theorem idea. So we know that since the average rate of change is 74 miles per hour, the instantaneous rate of change must have been 74.298 miles per hour at least once. The speed limit is at most 70 miles per hour. The mean value theorem guarantees that the driver was speeding at least once. So all we need to do now is get the state to understand calculus, and we will have a great source of income. So for example 4, we're going to find the equation of our tangent line to the graph of f of x. We're going to be on the interval 0 pi, and we want to know the point where we have a solution to the mean value theorem. So let's talk about the conditions. F of x is definitely continuous on our interval 0 to pi. If we take a derivative, f prime of x is going to be equal to 2 plus the cosine of x. And this also means that f of x is differentiable on 0 pi. All right, the next thing I want to do is figure out, since we know that the mean value theorem can be applied, we want to figure out where the slope of our tangent line is equal to the slope of our secant line. So find the slope of the secant line. We're going to have f at pi minus f at 0 over your pi minus 0. And that will give us a 2 pi minus 1 minus another 1 over pi is equal to 2 plus the cosine of x. Using well, we don't even need a calculator for this. We know that the cosine of x is equal to 0 when x is equal to pi over 2. So now we know that f prime at pi over 2 must be equal to 2. That tells us where we have our point. F at pi is equal to pi plus 2. We'll write the equation of our tangent line. Y minus the quantity pi minus 2 is equal to your slope, which was 2, times x minus pi over 2. So we have the equation of our tangent line written to where the slope of the secant line is equal to the slope of the tangent line. So now I would like you to give questions numbers 5 and 6 a try. Afterwards, complete the lesson follow-up.